Okay, last one we're going to do. So this is an actual law that exists in, chemistry, physics. Boyle's law. It has to do with if you have temperature of a gas that remains constant, it has to do with the relationship between pressure and volume. Okay, but don't freak out. Don't let your brain explode. Go through the steps. Step 1, this is the 4th problem, same step. Step 1, figure out what they're asking for. So I'm going to go to the end of the problem, and it says, at what rate is P increasing? I want to know what the rate of P is. Rate is derivative, so I want the derivative of P. That's what I'm trying to find. Step 2, I told you go through where all the other numbers are and identify what you're given. They told me V. V, not the derivative of V, just straight up V. If it was the derivative of V, they would have said the rate of the volume. But they don't here, they just say V, or volume. So I have 40 inches cubed. So they gave me that. They gave me P, the actual pressure, not the rate of pressure, obviously, that's what we're looking for. So that's 60 pounds per inches squared. What else? Okay, so I have this 14, and so they told me if V is decreasing at a rate of 14. 14 is a rate, that means it's a derivative, and it's the derivative of V. So they gave me dV. Here's what you have to kind of watch out for. Decreasing means going down. That means it's a negative number. Okay, whenever something's increasing, we give it a positive value. If it's decreasing, it's going to have a negative value. Write that in your notes so that you have it. Inches cubed per second. That was step 2. Step 3, I told you you're always going to have a formula. If it's not geometry, they'll give it to you, and they have right here. So my formula I'm working with is P times V equals some random constant. And now, in order to find the derivative of P, I need to take the derivative of my formula. And what I have here is a product. So I have to use product rule. The derivative of P is dP. So that's the derivative of the first times the second. Plus, the derivative of the second is dV times the first. All right, so I'm done with my product rule. Equals the derivative of any constant. A constant is just a number. Derivative of all constants are 0. Okay, so let's go ahead and fill in what we have. I'm looking for dP, so I don't have that. But I do have V. My volume is 40, so I'm going to put 40 in for V, and then I'm going to arrange the order. So I have 40 inches cubed, and then dP, because I don't know dP, plus dV, they told me, was negative 14. I got to scoot this over. Negative 14 inches cubed per second. That's dV times P. Oops, I can't see P. P is 60 pounds per inches squared. 60 pounds per inches squared. And that's going to equal 0. So my cleanup, 40 inches cubed times whatever dP is, plus negative 14 times 60 gives me negative 840. And then if I work on the units, I have inches cubed here on top. I have inches squared on the bottom. So those 2 inches are going to cancel with 2 of these, and I'm left with 1 inch. Nothing else cancels. So I have inches times pounds, inch pounds, inch pounds, and the seconds stay on bottom, so it's per second, equals 0. Move that 840 over. 40. When I move the 840 over, it becomes positive inch pounds per second. Okay, so I move that over. I got to divide by my 40. Divide by 40 inches cubed. All right, so the 40 inch cubes canceled. So I know that the change in pressure, the rate of change of the pressure, dP, 840 divided by 40 is 21. This inch here cancels with these, and I'm left with 2. 21 pounds per inches squared, which is a pressure measurement per second. And that is my rate.